2.1, complex numbers. Complex numbers is going to add in imaginary parts. It might have an imaginary part and it might not, but when we talk about complex numbers, usually we're talking about some sort of imaginary. So we've got this form a plus bi. So there's going to be a real part, like just a plain old number like 3, and then there may or may not be an imaginary part. So what we've dealt with, what you've dealt with most of your life is the real numbers. And real numbers are just like regular numbers that we've dealt with. You've got natural numbers. Natural numbers are numbers like when you count 1, 2, 3. And whole numbers is pretty much the same thing, except it includes 0, 0, 1, 2, 3. Integers throws in the negatives, like -2, -1, 0, 1, 2. These are all numbers that we like dealing with. Rational numbers is like, now it includes fractions. So 2/3 would be a rational number, or something that you could write as a fraction, like 0.5. Since that's 1/2, that's a rational number. When we talk about irrational numbers is like weird square roots, like square root of 7 or pi. Basically, it's decimal numbers that don't ever repeat or terminate. So really crazy looking irrational numbers. So these are all of the real numbers. But now when we talk about imaginary numbers, we're going to talk about basically the square root of -1. I is defined as the square root of -1. This is going to allow us to deal with some things that we couldn't deal with before. All right. So an imaginary number, I, is talking about a square root of a negative. So when we get to problem number 1, it says write the product of a real number and I. So since the square root of -81, we couldn't do that before. But we can think about it as the square root of -1 times the square root of 81. Well, we know, we just learned the square root of -1 is I, and the square root of 81 is 9. So we would simplify this and say that's 9i. Okay, so I want to do another one of those. If I said the square root of -36, you might be able to do that in your head because you know the square root of a negative is going to be I, and the square root of 36 is 6. So we can do some of this in our head. Part B is not going to be as simple, but we definitely know there's an I. And so it's going to be the square root of a -1 is I, and then there's going to be that square root of 55. The trick is if you can break down that 55, if you can simplify that 55, you would, but in this case, you can't. Now, sometimes people will say, well, what about, can I write it with the I in the back? And you can, it doesn't really matter, but you have to be really careful because sometimes we don't want to make it, we don't want it to look like the I is inside the square root. So if you write it that way, I would put a little hang down thing just to show that the 55 is under the radical, but the I is not. It's probably more standard to write the I in front of the radical. Part C, you've got an I and a square root of 98. Square root of 98 breaks down, and it breaks down, I know, because 98 is 49 times 2. So we're trying to look for perfect squares. We know certain perfect squares. We know the square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49. We know all these. Square root of 64, square root of 81, square root of 100. We know these and we know some more, but you're looking for ways to break your number down using those numbers. Square root of 98 is square root of 49 times square root of 2. So square root of 49 is 7. We've got the I from the front, and then square root of 2. So another example of that, if I gave you the square root of -50, we'd know there's an I, and the 50 can break down into 25 times 2. So that would be 5i times the square root of 2. Number 2, multiply or divide. Okay, so we're multiplying. We've got I times the square root of 21 times I times the square root of 21. I times I is I squared. And square root of 21 times the square root of 21 is 21. And I don't know what 21 times 21 is. What is it, 484? $441. But if you do the square root of 441, that's 21. Of course it is. That's what a square root is, a number times itself. So number times itself is just that, or square root times itself is just that number. Anyway, what's interesting about I squared, or I times I, is square root of -1 times square root of -1. So we just said a number times itself is that number, or a square root times itself is that number. So one thing you need to learn pretty quickly is that I squared equals -1. If I squared equals -1, you have -1 times 21 is -21. So, you know, what's tricky about this is sometimes people will say, well, that's a negative times a negative, that's a positive. But that's not how this works. We have I squared of 5 times I squared of 30. Now, I squared times the square root of, what is that, 150? So I squared is going to be -1, but 150 we have to break down, okay? So the best way to do this is if you know that can be 25 times 6. If you don't know how to break it down, one thing you can do is use upside down division. Always divide by a prime. 150 divided by 2 is 75. 75 is divisible by 5. 75 divided by 5 is 15. 15 divided by 3 is 5. And so the product of primes is 2 times 3 times 5 squared. That's 150. And if I took the square root of each of those, how this works, and you may remember this from algebra class, but you've got a root index 2, and you think about how many times 2 divides evenly into the exponents. 2 goes into 1, no it doesn't. 2 goes into 1, no it doesn't. 2 goes into 2, 1 time. So that's going to be a 5, and then the 2 and the 3 have to stay in. That makes 6. 5 squared is 6. Okay, it was much, much easier to recognize that 50 breaks down into 25 times 6 because the square root of 25 is 5, and you'd get 5 squared is 6, just the same. Since I squared is -1, we know there's going to be a negative in the front. We get -5 times the square root of 6. Part C, we have I times the square root of 42 over I times the square root of 3. I do 42 divided by 3. That's 14. Okay, I can do 42 divided by 3 is 14. So I'm going to have, well, what happens? The i's cancel out. The i's cancel each other out, and you're going to get the square root of 14. Square root of -63. So I've got I times square root of 63 over square root of 21. 63 divided by 21 is 3. So 63 divided by 21 is 3. That's square root of 3. You've got I times the square root of 3. Next, write in standard form. And if you look at this problem, it kind of reminds me of quadratic formula. This looks like a quadratic formula problem. So if you ever have to do quadratic formula and you get this, usually you want it in standard form. Standard form a plus bi, that means your real number part plus your imaginary number part. So we need to break down the square root of -75. That's going to be I times square root of 25 times square root of 3. So square root of 25 is 5. I'm looking at 15 minus, okay, this is a 5, right? So 5i square root of 3. over 5. Now, you can split this up. It's like you're distributing the division. It's like distributive property of division. You have 15 over 5 minus 5i squared of 3 over 5. I would prefer that you did that step in your head and could reduce that in your head. I call it V canceling. If all three of those numbers are divisible by 5, then you can do it. You can reduce it. Otherwise, split it up like I've done. 15 over 5 is 3. These 5's cancel. I get minus I squared of 3. So this is your standard form. So this is your standard form. I've got a real number part, 3, and I've got an imaginary part, negative square root of 3. Number 4, find each sum or difference. That's going to be pretty simple because we're just combining like terms. I've got the real number part, 4 plus negative 5 is negative 1. I've got the imaginary part, negative 5i plus 8i is plus 3i. The next one, subtraction, is a little bit harder. You've got to remember that you're subtracting both of those pieces. You're subtracting a 5 and you're also subtracting a negative 3i. A lot of people will miss that second negative. So I've got real number part, negative 10 minus 5 is negative 15. And I've got imaginary part, 7i plus 3i is plus 10i. Sometimes students get tempted to reduce that or something and divide by 5, but there's nothing that says divide by 5. That is what it is. You've got negative 15 plus 10i. That's simplified. You can't reduce. It doesn't say to reduce. Next, powers of I. This is going to be important for simplifying problems like number 5. We already know that I is equal to the square root of negative 1. You got to know that. So it helps if you know a little bit more. Anything to the 0 power is 1. That's the same as it's always been. I to the first, of course, that's what we just learned. That's I. I to the first is I. I squared, though, this is an important one. And we already talked about it. If you had I squared, that's I times I, or square root of negative 1 times square root of negative 1. And a number times itself, a square root times itself is just that number. So I squared is negative 1. That's important. You need to learn that. You need to memorize that. I cubed, we can think of that as I squared times I. And if I squared is negative 1, we just learned that, times I, you get negative I. So I cubed is negative I. Those 4 right there are really important. You got 1, I, negative 1, negative I, because they just keep repeating that pattern. If you look at I to the 4th, you could say, well, that's I to the 3rd times I. And I to the 3rd is negative I times I, that's negative I squared. And I squared is negative 1, so you have negative negative 1, which is positive 1. 1. I to the 5th is I to the 4th times I. Well, I to the 4th we just found was 1, so that's 1I. I to the 6th, we could say that's I to the 4th times I to the 2nd if we want. I to the 4th we learned was 1. I to the 2nd we learned was negative 1. That's going to give me negative 1. You see this pattern just keeps repeating over and over again. 1I, negative 1, negative I. That's going to be important, all right? So we can figure out higher powers of I using that pattern. So when I see I33, I want to figure out which of those 4 values it is. All right, is it 1, I, negative 1, or negative I? The easiest thing that you can do is split up the 33 into some way, like I have with those examples up there in red. You want to split it up, but the easiest thing you can possibly do is use a multiple of 4, because every multiple of 4 is going to be 1. If I said I to the 8th power, that's going to be 1. So I9 is I, and I10 is negative 1, and I11 is negative I. But when we get back up to I12, that's going to be 1. So every single multiple of 4 is equal to 1. So what you can do is call I33 I32 times I to the first. And I33, because of this pattern, I33 is going to equal 1. Every single multiple of 4 is going to equal 1. So we have 1 times I, which is I. There are a lot of different ways you can split it up, but I think that is the easiest that you can do. Now, I negative 14, I think negative exponents are a little bit hard. One thing you can do is you can say, well, the negative is going to move to the other side of a fraction if you want, and then do the same thing. I14, split it up into a power of, or a multiple of 4. So I14, you could write it as I12 times I squared. And I12 is 1, and I squared is negative 1. You can have 1 over negative 1, which is negative 1. Another way to do that more directly, I think it's a little bit harder to think about, is if you say, well, I negative 14 is equal to I negative 16 times I squared. And I negative 16 is your multiple of 4. So that's 1, and I squared is negative 1. That's negative 1. Either way. I know students struggle with this, so let's do one more example. If I did I don't know, 26. Okay, I26. The way I would do it is say that's I24 times I squared. I24 is a multiple of 4, that's 1. I squared is negative 1. 1 times negative 1 is negative 1. They're all going to be kind of the same thing. Split it up into a multiple of 4 and whatever's left. Next, example 6, we're going to have to distribute. This is a multiplication problem. So let's check it out. Treat the I just like a variable. I'm going to distribute the 5. I've got 5 times 2 is 10, and 5 times negative 7i is negative 35i. I'm going to distribute the 3i and get plus 6i minus 21i squared. So we've got like terms. Negative 35i plus 6i is negative 29i. And I squared is negative 1. So you're going to have negative 21 times negative 1 is plus 21. So I've got more like terms now. 10 plus 21 is 31. 31 minus 29i. Notice that's in my standard form. You've got a real number part, 31. An imaginary part is negative 29. Part B, everybody screws this up. Don't be that guy, all right? You cannot distribute the 2. It is not distributive property. You cannot distribute the 2 across subtraction like this. What you have to do is think about this as 4 minus 5i times itself. That's what squared means. Something times itself. So it's the same problem as part A now. You're going to distribute. 4 times 4 is 16. 4 times minus 5i is minus 20i. Now distribute the minus 5. So we did this one. Now we're going to do this one. Minus 20i plus 25i squared. Like terms, that's going to be minus 40i. You have 16 minus 40i. And then 25 times negative 1 is minus 25. 25 times negative 1, right? So we have 16 minus 25 is negative 9. Negative 9 minus 40i. A lot of people are going to try to distribute this exponent. Please don't do that. You can't do that. It's not allowed. Next one, kind of the same deal. 9 times 9 is 81. 9 times 8i is plus 72i. Negative 8i times 9 is minus 72i, and 8i times negative 8i is minus 64i squared. Remember, I times I is I squared. In this case, the 72i's cancel each other out, so that's actually good. You have 81, and you have minus 64i squared. Remember, that's negative 1. So negative 64 times negative 1 is going to be plus 64. 81 plus 64 is 145. So that's still a complex number. It's just all real. You don't have an imaginary part. So if you had to write it as a complex number in standard form, you could think about that as 145 is your real part and 0 is your imaginary part. Now, number 6 was multiplication. I want to go back real quick and look at number 4. Look at how much easier number 4 was when we added or we subtracted. Don't get confused and make sure you pay attention to whether the problem is saying add or subtract or multiply. Very important, very common mistake that people make. Last one, when we divide, I think this problem right here, 6a, is probably the hardest problem. Okay. Essentially, we're not allowed to have an I on the bottom. Okay, we're not allowed to have an I on the bottom. And in part B, it's an easy fix. Let's do part B first. What we can do is similar to when we do other fractions. We can manipulate it by changing it. Okay, so if I had 1/2, I could multiply by 3/3 to change it to 3/6. That kind of thing came in handy for when I was adding fractions and needed a common denominator. What I can do is multiply times 1 in a special way, and it produces a result that still equaled 1/2. It still equaled the same thing that I started with. I'm going to use that concept to get rid of my I on the bottom. Okay, so the kind of the secret is to go through I squared. So if I multiply this one by I over I, that's a special form of 1. I'm multiplying by 1, so I'm not changing the value of my fraction at all. It just is going to look different. I've got 15I over negative I squared. And this is useful for me because I know that I squared is negative 1. So this says 15I over the opposite of negative 1, or 15I over 1, which is just 15I. Okay. I'm not allowed to have an I on the bottom. I used that trick to do that. Now, in part A, it's harder because you can't do the same trick. So don't write this down. I'm going to show you something that's wrong first. Don't write this down. If you tried the same exact trick, what ends up happening on the bottom is distributive property, and you turn it into 3I plus I squared. Okay, if you distribute like that. Now, I squared is -1, so that's good, but you've just carried the I over onto the other part of the denominator. You still have an I on the bottom. That's not ideal. We don't want that. We don't want an I on the bottom. And so the trick that you use here is called multiplying by the complex conjugate. And so what we're going to do is take that bottom part and multiply by 3 minus I. Whatever this sign is, we're going to multiply by the opposite sign right there. So everything's exactly the same except change the sign. If that was a minus, we would have used a plus. But I want 3 minus I over 3 minus I. Again, the whole secret is that's 1. That 3 minus I over 3 minus I is 1. So I'm multiplying by a special kind of 1 that's not going to change the value of my original problem. Now, we're going to do what we just did a minute ago on the previous example where we had to FOIL. But if you notice in problem 6c, when we had that conjugate situation, you didn't pay attention, you didn't notice this, but 9 minus 8i and 9 plus 8i, the fact that one of them is minus and one of them is plus was the reason why those two i's canceled each other out, and we got something that didn't have an I on it. Okay, that's the key, and that's what we're going to do. So it doesn't really matter what we get on the top, but what we get on the bottom, that's where your I is going to disappear. Okay, so let's distribute on the top. 5 times this is going to give me 15 minus 5i, and negative 5i times this would give me minus 15i plus 5i squared. Minus 5i times minus I is plus 5i squared. All right, so now let's do the bottom. Bottom, distribute the 3, and you have 9 minus 3i. Distribute the I, and you're going to have plus 3i minus I squared. Excellent. So notice those 3 i's cancel out. Okay, those 3 i's cancel out. Sometimes people will try to somehow reduce that 15 and that 9. That's not how it works. Okay, order of operations says you have to do the entire top before you can get to that division. All right, the top is a fraction. You have to simplify that top. You have to simplify the bottom, and then maybe we can divide. All right, so a couple of things. Up on top, I have a like term. Negative 5i minus 15i is minus 20i. So I have 15 minus 20i, and then plus 5i squared. Remember, that was negative 1. So 5 times negative 1 is minus 5. And on the bottom, I have 9. And if I squared is negative 1, I have minus negative 1. That's plus 1. So we can do like terms again. 15 minus 5 is 10. I have 10 minus 20i over 10. And then the last thing I want to do is reduce. If you split it up, it's a little bit more obvious maybe. Basically, I'm distributing my division. And I can reduce that fraction. 10 over 10 is 1. Reduce that fraction. 20 over 10 is 2. I have 1 minus 2i. That's my simplified reduced form. Now, if you can recognize back here, you can save yourself a step. I call that V-canceling. If all 3 of those numbers are divisible by 10, you can reduce that. So since all of those are divisible by 10, if I reduce, I get 1 minus 2i over 1. But again, I just get this, 1 minus 2i.